Let's graph the solution to the system of inequalities. We'll start by graphing the first line. Change that top inequality into an equation. Isolate the y. We'll start by subtracting x and then divide both sides by 2. Y is equal to negative 1/2 plus 2. The y-intercept there is 2. The slope is negative 1/2. So down 1, right 2, down 1, right 2, or up 1, left 2. Notice the original inequality is strictly greater than, so this is a dotted line. And now we want to test a point to know where to shade. And we can test 0, 0. Remember to always test in the original inequality. In this case, x plus 2y is greater than 4. 0 plus 2 times 0. We're asking, is that bigger than 4? 0 is greater than 4 is a false statement. So since 0 is down here and it was false, everything on this side of the line is false. That means we need to shade above the red. So I'm going to make a mental note of that for later. Next, we'll graph the bottom inequality. Start by making that an equation. Subtract 2x on both sides. Divide by negative 3. And y is equal to 2/3 x plus 2. So in this case, we get the same y-intercept. The slope is 2/3, so up 2, right 3. Or we could have gone down 2, left 3. And look at the original inequality. We have equal to, so this is a solid line. And now we want to test a point. We can test any point that's not on the line we just drew. Again, 0, 0 is a good starting place. And we'll test in the original inequality. So 2 times 0 minus 3 times 0. We're asking, is that less than negative 6? In this case, we get a false statement. We chose 0, 0, and it was false. That means we need to shade above the blue line. So we want to shade the region that is both above red and above the blue. That's going to be this region, between the red and the blue, above red, above blue. In our next example, we want to look at x is less than 3. We'll start by changing that to an equation. X equals 3 is just a vertical line, but notice it's got to be dotted. So we have a dotted vertical line. And choosing a test value, we don't really need to choose a test value here. We can just look at the inequality. We've got to be less than 3. So we're going to shade to the left of the red line. And then with the next one, we have y equals 1. We'll change it to an equation. And y equals 1 is just a horizontal line. And notice it has equality on it. So this will be a solid line. And testing, again, we don't really need to test a point because we can see from the equation that y is bigger than or equal to 1. So we're going to shade above the blue. So we want to be to the left of the red, but above the blue. So every point in this region is above blue and to the left of the red. In this example, we'll start by changing the top inequality to an equation. Y equals 2x minus 3. The y-intercept is negative 3, and the slope is 2. Up 2, right 1, up 2, right 1, and so on. This is a dotted line due to the strict inequality. And again, we want to choose a test point. Let's test 0, 0. We'll test in the original inequality. y is greater than 2x minus 3. So is 0 bigger than 2 times 0 minus 3? 0 is greater than negative 3. That's a true statement. Since we chose this point, the origin, and it was true, every point on this side of the red line is true. So we want to be to the left of the red, or you can think of it as above the red. The blue, again, we'll change it to an equation first. Y equals x minus 3. Now let's graph that. We have the y-intercept at negative 3, and the slope is 1. So up 1, right 1, up 1, right 1, and so on. And this again is also a dotted line because of the strict inequality. Now test a point. Let's test 0, 0. Testing the original inequality. Is 0 less than 0 minus 3? 0 is less than negative 3. That is a false statement. We chose 0, 0, and it was false. That means we need to shade to the opposite side of the blue. So we will be below blue. So the region that we shade has to be to the left of the red and below the blue. That's this tiny little wedge down here. Now that does go on forever. In this example, we'll start by graphing the top inequality. Make this an equation, and let's solve for y. Subtract x on both sides, divide by negative 1, and y is equal to x minus 1. So the y-intercept is negative 1, and the slope is 1. Notice that this is a dotted line. Choose a test point. We'll test 0, 0 in the original inequality. 0 minus 0, and we're asking, is that true? 0 is not greater than 1. We chose the origin, and it was false. That means every point on this side of the line is false. It also means that every point below the line has to be true. So we will shade below the red. Now let's look at the blue. Change this to an equation, x equals negative 3. That is a vertical line, and it is solid because we have an equality there. So solid line at x equals negative 3. And we are shading to the right of negative 3. We don't need to choose a test point because we know it's bigger than negative 3. So to the right of the blue line. So our answer needs to be below red and to the right of blue. Every point in this shaded region is below red and to the right of the blue. So every point in that region is a solution to this system of inequalities.